Welcome all of you to the data mining course. In this course, we will cover the basic concepts and techniques of data mining. So the book we used for this course is Data Mining Concepts and Techniques, third edition, authored by Jia Wei Han. So we start. So first question is why we use data mining. So this age is in fact is the information age, and there is the advent of data science in this age because we encounter a huge amount of data on daily basis through our online transactions, through web search, through the real-time applications for video conferencing, and there are data for video streaming applications on YouTube, and there are some social media applications which generates a huge amount of data. So this data belongs to several businesses. This data belongs to different social networks. This data belongs to different real-time traffic or real-time networks in terms of IoT. And in fact, we are living in a computerized society where we have everything in the digital form now. So this data is available for analysis, and we want to extract the useful information from this data for some analysis, for some future decisions, for prediction. And this can be done if we are able to extract some useful patterns from this data. So in fact, the data in raw form is nothing. So we are in fact drowning in a tremendous amount of data, but we are starving for knowledge or information. So what this knowledge is in fact is the useful patterns or the information required by you or any of the person want to access from this data. So necessity is the mother of invention, and we have the data mining. Data mining is in fact is the automated analysis of massive data sets. So by applying data mining methods, we may able to analyze these patterns extracted from this data. So uh, what is data mining? So if I say that data mining is the knowledge discovery from the data, or we can say the extraction of interesting patterns uh, or knowledge from huge amount of data. So this can be seen as that if this data is not uh, have some specific patterns to be extracted, then this data is not useful. So because without making a strategy or using some data mining methodology, we are not able to extract the information from this data. So we have alternative names. These alternative names is knowledge discovery from data, KDD, and the knowledge extraction and pattern analysis or information harvesting or business intelligence. So these are the alternative names which we can use for data mining. Itself, data mining is not so meaningful word which can identify the data mining methodology. So, so in fact, this data mining methodology is useful in KDD process that we extract the knowledge by the process of data mining. And this data mining process is involved in this KDD. So uh, let's look uh, at the systems uh, where we reside our databases, and these databases are meant for the purpose of cleaning and integration of data from different sources. And these data from different sources are located at a single site, which is called data warehouse. So in data warehouse, we store the data in the form of flat files or arrays from which we have the selection and transformation uh, for the data to be mined. So after selection and transforming the data to be mined, we put it in the data mining process, or we apply data mining methods to extract useful patterns from this, and then we evaluate these patterns to get the knowledge from this data. So the knowledge discovery uh, involves the steps you have seen in the picture. So what we know that data cleaning or filtering, so it is in fact is the removal of noise or the removal of irregular data from the uh, data set. And then we have the data integration, where we integrate the data from multiple sources. And then we have data selection. So we use the relevant data for the analysis task, and then we transform this data to the uh, appropriate operations for mining. And data mining is in fact is the intelligent method which is applied to extract data patterns, and these data patterns are evaluated and presented to the end user. And this presentable patterns in the data sets are the useful information and knowledge for the user. So from machine learning and statistical point of view, we have the data pre-processing, which you have seen that the first steps from data cleaning, data integration, data selection, and data transformation. So all the steps are included in the reprocessing of data. And then we have the data mining. And after data mining, we have the post reprocessing, which we use pattern evaluation or some presentable method in which the knowledge is presented. So we have this pattern information or knowledge is presented to the end user. So data mining methods are of interest in this course, and today we will have the brief introduction of these data mining methods. But before this, we learned that what kind of data can be mined. So this data is in fact is from the database, from a data warehouse, or from a transactional data. So there are the three main categories which we in fact uh, mine the uh, data for the target application. There are other types of data from data streams, ordered sequence data, graph or network data, spatial data at different locations, temporal data at different time instances, spatiotemporal data, textual and multimedia data, and the web data. So all these type of data can be mined, but keep in mind that these new uh, data to be mined is a challenge in this course, and at the end of the course we will see some methods to explore some ways to mine multimedia data or some social media or web data. So the most interesting thing is that the first part here is in fact is that we mine the data for the target application from a database data. So what is database data? So this database data is in fact is uh, the uh, data using database management system. Database management systems are used for the collection of interrelated data known as database, and a software program manage and access all this data. What is the purpose of this software program to store this database? So database in fact is the storage of the data uh, which is interrelated, and we use a software program, a set of software programs to manage and access this data. So the software program provide mechanisms for defining database structures and data storage. So that is in fact is helpful for storing data. It is just like you have a specific file system for database management, and for then you have the concurrent shared or distributed data access. So you can access this database in parallel shared mode or in distributed data access So keeping in mind the consistency and the security of the information stored. So in fact, for example, the data is consistently modified and it is secure for all intrusions, all external intrusions. And this software program for database management will also keep the consistency and security of the information store. So we have the relational database, which assign unique names to tables. For example, in a database, you have the unique tables, and these tables consist of columns, which are called the attributes. And each attribute have a large set of uh, records, and these records are stored in the rows. So each record or row is in fact identify a object, uh, and this object have a unique key in the database. So this unique key is described by the attribute value. So it is just like we see a simple 2D table, and uh, in this table we have uh, we have multiple columns, and these columns are the attributes A1, A2, and A3 and A3. Now, in fact, these columns have different, uh, these are the attributes of the table. And these are the, in fact, these rows are the tuples which identify the objects with a unique key. Let's say we have the key 1, key 2, and key 3. For example, this key might be a customer ID, and a attribute will be the customer name, age, income, and sort of attributes which are useful. So these attributes are in fact of the dimension of the database. So if there are three attributes, it has three dimension. If it has one attribute, it has only one dimension. So this in fact is in data set, we call this the sample, and this sample belongs to a real object in the real life. In real life, it's an object. A customer is a real person, which is called object in real life, but in data set, we call it a sample. For example, this is one sample have some particular values, and we have the information about it. So this is in fact is the database is stored in the form of tables, and there are multiple tables which are interrelated for record keeping. For example, we may define a class with more than one attribute, or we have the relation between the two attributes to find that which is the potential customer. So this is in fact is the if we just keep track on the single attribute, so it means that we are defining or determining the user potential to buy a product on the single dimensional attribute. So, so these are the very important terminologies related to database data, and there are semantic data model, which is in fact is the entity relationship data model, is often constructed from these relational databases. And in this entity relationship data model, the database are represented as a set of entities and their relationships. So now look at an example. So all electronics is a fictitious store, right? Throughout the book, we use the example of all electronics store. So all electronics store means that all the daily life electronic devices, including home appliances and the security devices of electronics, are sold from this store, and this store is in fact is taken as an example throughout this book. So we have the relational table, and in the relation table we have the customer, item, employee, and branch. So we have the header of the table described as shown in the figure. So this header is in fact is the schema of a relation. So this in fact this header is in fact is the schema of a relation. So if we have the data from different sources, so we have the unified schema. So every customer have a unique customer ID, customer name, and address, age, occupation, and annual income, and credit information and category. Similarly, each relations item, employee, and branch consist of a set of attributes describing the properties of these entities. So, so at every branch, you have the list of relation, the item to be sold, the employees or salesperson working, and the name of the branch. So these are the attributes. Uh, so tables can also be presented the relationship between or among multiple entities. In our example, these include purchases, or this includes items sold, and employees works at all branches. So, so we have in fact the relationship between the multiple entities, or so this multiple entities in fact is uh, uh, have the relationship among each other. So, so this is in fact is the relational schema for relation database. So, for example, we have the customer. So we have the information about the customer. We have the information about the item. We have the information about the employee. We have the information about the branch. Now, these three, in fact, are the relational schema which keeps record of purchases and items sold, and the salesperson selling this good. So you can keep track record of all these relational relational schemes. So relational query language like SQL is used to transform relational operation. For example, if I just generate a query, show me the list of items sold in last quarter. So this query will show me all the list of items sold in the last transactions by calling the item ID. So it is in fact is it presents the summary at the data warehouse from where you can access uh, the summary of the quarter. So because you have the value of the quarter as well. So example of relational database is uh, so data patterns can be extracted from a relational database. For example, if we want to determine the credit risk of a new customer based on age, income, and previous credit history, so we can determine this. So this is, in fact, we learn about database, and now we learn about data warehouse. So data warehousing is in fact, for example, if the all electronics president wants to see the per item sale of all branches around the world in each quarter to find the best time to order stock. So if this is, if you just have a view for a few seconds and you can pause your video to think over it. So what problem it is? So all branches sale record required and only be available if stored at a single location called data warehouse. So in short, a data warehouse is a repository of information collected from multiple sources stored under a unified schema. So I have already shown you what is meant by unified schema, that the headers is uniform in data warehouse. So data warehouses are constructed by a process of data cleaning, data integration, data transformation, data loading, and periodic data refreshing. Because we keep on updating the record, and we generate the summary of all the possible queries which are frequently addressed by the president. So it keep record of all the things in a summarized manner to be presented to the president whenever it is required. So we have, in fact, data warehouse have a multi-dimensional database depending on multiple attributes. It may be a data cube having three attributes and three dimensions. It supports the quick access of data by pre-processing and fast access to the summarized data. So, in fact, storing the information in a two-dimensional database, we are storing the information in the form of cubes, which is in fact is which is in fact is three-dimensional. So it is a multi-dimensional cube, which you have the multi-dimensional, and you have the analytical processing of you have the online analytical processing to address the queries at different level of abstractions. Uh, so you can have address the query at different uh, different ways of accessing your data. So at you can ask from considering any of the attributes or any of the combination of the attributes, so you can generate a query. So online analytical processing supports roll up and drill down operations. So this will be covered later in detail in chapters, but see that the all electronics have the four electronic devices, four type of electronic devices: home entertainment, computer, mobile phones, and security devices. Sold in quarter one, quarter two, quarter three, and quarter four in USA and Canada locations, Chicago, New York, Toronto, and Vancouver, and all the sale record. So the value of the attribute in the column will represent the amount of sale in this quarter for the home entertainment. So you have the drill down operation and you can scroll for the sale record for every month. So all columns are not filled for the visibility of the cells, but in fact you have the value in each cell. So you can have the record by drilling down the quarter one record, and you have the January, February, and March values of the sales. And similarly, you have the roll up operation, and you can have collectively check the USA and Canada sales in the first quarter for home appliances. So you have the drill down and roll up operation in OLAP. So we study so far about database, how to retrieve, data from the database. And what is the database? And we can mine data from the database, and we can mine data from the data warehouse. And actually, in fact, the data belongs to transaction. For example, I purchase an online ticket from the airline company. So it is a transaction. I go to a supermarket and buy groceries. So I will have one transaction in which I have purchased several items. So this is in fact is the transactional data. So this transactional data is important in strategy making. For example, we have a strategy in a supermarket that usually the person comes and buy bread, milk, butter, cheese, and eggs together. So we place all these things at the same location. The probability of buying eggs with the bread and milk is higher than the person who buy only bread. So this will affect the sales. Also, we have a possibility. We have a possibility that Uh, we want to check that which items are purchased together in the grocery store. So we check the grocery store and we want to evaluate that during this month there are 1,000 transactions, and in how many transactions, how many goods are purchased together. So this is the affinity problem. So this affinity problem is useful. So in the affinity problem, we have checked which items are purchased together, and we apply some rules to check the purchase of items together, or the purchase of items with some level of sport and confidence. So, sport and confidence is a measure that where how these two things are purchased together. For example, we say that a person buy a computer, buy the software, and we have a sport 1% and confidence 50%. So the sport means that there are 1% transactions in which customer buy a computer and software together. So if there are 100 transactions, so in one transaction, the person buy computer and software together. So the confidence is the probability that a person buy computer will also buy software. So that probability is 50%. So these are the two measures. There are several other measures as well, but at the moment we will consider sport and confidence as a measure for this affinity problem. So we will discuss later on Bayes, because this is also called the association as well. This is also called the association rule. So other types of data. So other types of data is like there are bank tellers sitting in the bank, and according to the customer trend, you schedule the bank tellers, and the stock exchange trend for right time to invest money. So there are some time-based data, and there is some data which depends on the demographic conditions. For example, the income of the person in Islamabad is higher than the income of people in Lahore, or the income of people are varying by different cities. In big cities, people have high income. And this demographic condition affect the sales as well. So this is in fact is the spatial data. Also, if you want to install a new production unit, so you can check the consumption of a particular good at this location. So this data is also useful for the installation of new production unit. So this data is spatial data, and that is of tremendous use. Also, we have data from data streams that is used for video surveillance and sensors data. So this is in fact is the real-time applications, and data streaming is monitor for some purpose of surveillance, and for some identification of critical uh, uh, critical data application, which is acquired uh, data from sensors. So hypertext and multimedia data identify objects by semantic labels, and this is also in fact is frequently used on Google and YouTube. So network data, monitor network data traffic to find some intrusion uh, over the network, and so on. There are many other applications for other data. So moving forward, so this is all about we learned at what kind of data can be mined. So now we learn what kind of patterns can be mined. So what kind of patterns can be mined is in fact is the data mining functionalities and data mining tasks. So data mining functionalities in fact is the characterization and discrimination, association and correlation, classification and regression, clustering analysis, and outlier analysis. So now we put light on these data mining functionalities, and we relate this with the data mining tasks, which are descriptive and predictive. So first we see the data characterization. So we move on to the example of all electronic store, and we have the classes of items for sale are computers and printers, and concepts of customer are big spenders and budget spenders. So in fact we have the data characterization is the summarization of the general characteristics or features of a target class of data. So, for example, if I say that if I target computers or target printers independently, or we target computer and printers sale altogether, so this is in fact is the target class. And concept of the customer is in fact is the two concepts, which is the big spenders and budget spenders. So data corresponding to the user specified class. So this is in fact is the user specified class, big spender and budget spenders. So this can be addressed by uh, 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 the query generated uh, regarding this. So we look on this example. So we have a data mining task. So we want to judge the customer who spent more than $5,000 at our electronics store. So the general profile of these customers, such as they are 40 to 50 years old, employed, and have excellent credit ratings. So this is in fact is what it returns against the salesperson query. So these are the customer uh, customer attributes that it is 40 to 50 years old, employed, and have excellent credit rating. So this is in fact is the data characterization. Now we have the discrimination. Now we compare the two classes. And so we in comparison, we use the general features of the target class of the data. So with one or multiple contrasting classes. So the target and contrasting classes can be specified by a user, and the corresponding data objects can be retrieved through the database queries. So I give you an example. So we want to compare that which product which software product has 10% increased in sale in last year, and we compare it with the one whose have decreased in 30% sales during the same period. So these are the two software products. So this is in fact is the data discrimination problem. Now we have a look about the frequent patterns. So frequent patterns, as the name suggests, are the patterns that occur frequently in data. So these may be the frequent item sets, frequent subsequences, or the frequent substructures. So the frequent item sets uh, refers to a set that often appear together. For example, milk and bread are frequently bought together. So these are the frequent patterns. And frequent structure. Frequent structure is in fact is the representation of this in the form of graph, trees, or lattice. So we have the frequent sequential pattern. For example, we say that a customer first purchase the laptop and then purchase the digital camera and then purchase the memory card. This is the sequence of purchase, and that is the frequent sequential pattern followed by the customers. So based on these frequent patterns, we discover some association and correlations within the data. So these frequent patterns help us to determine the associations and correlations between the data. So now what we have learned earlier, so have a look over the association analysis. So there is a single dimensional analysis based on one attribute, which is attribute is by computer and by software. So by computer and by software, with first is the sport and second is the confidence. So it means there is one attribute by, and it is a single dimensional association analysis which have 1% support and 50% confidence. And in affinity problem, we have already seen the meaning of support and confidence. That among all transaction, 1% transactions are those transactions in which computer and software are purchased together. And in 50% confidence, that there is 50% probability that the person buy the computer will also buy the software. But there are multi-dimensional association analysis. For example, among all the customer of all electronics, there are 2% are in the age of 20 to 29, and they have the income in the range of 40 to 49,000 dollar. They have purchased a laptop. So there is a probability of 60% that customer in this age and income group will buy the laptop. So now the attributes here is the age, income, and buy. So there are three attributes. So age is in this range, income is in this range, and they will purchase the laptop with a support of 2% and confidence of 60%. So association rule must have the level of interestingness. So if there is no level of interestingness, then it is not useful. So the level of interestingness means that they must have the minimum support threshold and minimum confidence uh, threshold. So you have to set the minimum value of support and confidence for the association rule, otherwise it's not useful. Now we use the classification and regression for predictive analysis. So classification is the process of finding a model or function that describes and distinguish data classes or concepts. So in fact, you define a mathematical function. You define some criteria to classify the problem, so that if you have the data objects with class labels unknown, uh, the model is used to predict the class label for the objects uh, for which it is unknown. So, so it is just I say that the classification problem is this classification process is in fact is describing a model to classify the data with unknown labels to give them a some label that it belongs to which class. So that is in fact is a sort of that is in fact is a sort of supervised learning that you have for every x, you have a function f of x, which describes the model. And in fact, when you train the data, so you can say that you will find some attributes, or you will check some attributes of this x, and you will put it in to some class. After checking the attributes, you will put it into some class, and you will check the attributes at different points. So at the end of the attribute, so you will give in them a label A, B, or C. So before going into detail, I try to explain this. For example, we have the customer, and the customer may be of any age. It may be a youth, it may be a middle-aged, or it may be a senior. So if it is a youth, so it income is high or low, or if it is the middle age, the income is zero, and if it is a senior citizen, income is also zero. So we put with the middle age and senior citizen into class C. So this is in fact we have three classes here. Youth with high income is a class A. Youth with low income is a class B, and middle aged and senior citizen without any income belongs to class C. So it means that we classify it into three classes: class A, class B, and class C. So it is in fact is the classification problem. So this is in fact is the if then. It is called if then rules. So this is the classification rules, and it is called if then rules. And there might be a tree structure where this is the attribute. First attribute we have chosen is the age, because the most common of them is the age, and from age we have categorized middle-aged and senior citizen, and we label in to class C. And then we choose another attribute of income for youth only, and we make a decision on the basis of this attribute, and this have high and low income, and that belongs to class A and class B. So this is in fact is the class label, which is class A, class B, and class C. So every class has some label. So when you have a data which is which don't have any label, so you will pass through this tree and give them some label. So similarly, we have the neural networks. So it is a two-layer neural network. So in which we have the age and income. We apply the function weights, and we will split it into uh, three uh, attributes, three functions, and then we have finally have the three classes in this neural network. So, so if I say that if some data is unlabeled, so that particular data object will assign some label on the basis of this classification function or classification model. So you have seen three models. You have seen if-then rules, decision tree. I have tell you little bit about mathematical formula, and I have also tell you about the neural network. But there are other methods as well in which the most common are naive Bayesian method, support vector machine, and k-nearest neighbor. So in the later classes, we learn about these methods as well. So classification models are used for discrete and unordered labeling. So you can see that the class labels are on discrete values. For example, age is a discrete value, and the income is also a discrete value on which you will take or classify the problem. But in regression, so you have the continuous value function and used to predict the missing values from the data. So, for example, if data has some missing value, you can predict the value of the data. So, so the attributes, all attributes of an object are not interesting for classification and regression analysis, and which are not interesting will be avoided. So this is a classification and regression problem that the All Electronic Store has a marketing campaign, and they have three type of responses. So good response, mild response, or no response. So this is in fact is are the three classes. So you want to drive three classes based on descriptive features of the items such as price, brand, place, made, type, and category. The resulting classification should maximally distinguish each class from others, presenting an organized picture of the data set. So I'll give you this assignment, and you will make the decision tree to classify this, and you can check whether it how it could be useful. So sometimes uh, we have uh, we have no class labels. We cannot classify the data by classification and regression method. And we use clustering for grouping the data. So we have the 2D data, and this 2D data is plotted on the graph, and based on the similarity, we group this data. So what we want in clustering is that we maximize the intra-class similarity, that the similarity within the class will be increased and similarity between the two classes will be decreased. So this is in fact is the clustering problem. So for clustering, you have seen the example in the all electronics customer data to homogeneous subpopulation of customers. We use to target different groups for marketing based on their locations in the city. Now we see that there is anomaly in the data. There is, like we see here, the cluster example, these are the anomalies which deviate, or so these is in fact are ignored or in the outlier analysis. So we ignored these points because there are very few samples which lies in the outlier analysis. So if we also in statistical model, we perform different statistical tests to uh, measure the accuracy of the model, or to measure the outlier analysis uh, for a particular anomaly. Or in clustering, we have the distance measure for objects. Also, we have the distance measure in regression analysis of objects from the regression function. Now, uh, just have a look that all patterns interesting. So if they are not interesting, so they contains no knowledge. So a pattern is interesting if it is easily understood by humans. It is valid on new or test data with some degree of certainty. It is potentially useful and it's novel. Actually, the user make a hypothesis, and in its hypothesis, he just make some assumptions. So that assumptions are not perfectly true, and due to this assumption, there is uncertainty to confirm the pattern. So it is in fact this pattern is the level of interestingness depends on how accurate the hypothesis made by the user. So it is the level of interestingness is higher if the hypothesis is confirmed. So the objective measure of pattern interestingness in terms of statistics related to its association rules is determined in terms of support and confidence. And in probabilistic terms, we determine it is the probability of X union Y. So confidence X implies Y means probability of Y given X. So these are the two important objective measure of interestingness for association rules. Other objective measure of interestingness are accuracy and coverage. Accuracy tells the percentage of data correctly classified by a rule. So the accuracy is in fact is defines the percentage of data correctly classified, right? And the coverage tells us the amount of data over which the rule applies. So the accuracy and coverage are the two other objective measures of interestingness of the pattern. So we have the subjective interestingness measures. So it is for a pattern that are unexpected or offer some strategic information. For example, a large earthquake follows by a cluster of small quakes, and you have the preventive measures based on this analysis. So this is the subjective interestingness measures. So data mining is an interdisciplinary course which depends on the mostly on the target applications, and it uses several statistical models, pattern recognition, machine learning, visualization, and using database technologies and other algorithms. So it also use high performance computing, HPC, for mining data patterns. So it is an interdisciplinary area of research. So the level of interest in this will be increased by the the advent of data science age, and by in fact is the new area which is introduced in the field of uh, science, which is data science, and we are handling big data these days. So the dependency over high performance computing and the robust algorithm is very high. So data mining is used for business intelligence because the strategy to launch a product is a critical decision in the business model. And in this model, we want to increase the potential to support business decisions. And these decision makings have this pyramid where we have the sources of data from different ways, and then we, pro- we process, integrate, and we data warehouse, and then we have the statistical summary, querying and reporting for data exploration, and then we have the data mining, uh, and then we have the data presentation visualization techniques, and from these visualization techniques we get the knowledge, and then we have the decision. We are capable to make decision. So this is in fact is the database administrator which manage this task, and there is the data analyst who manage the task. And data presentation is the business analyst, and this is the end user, which is the decision maker. So other example of data mining is the healthcare and medical data mining. Uh, so it take use of statistics and machine learning. So first we have the pre-processing of the data, including feature extraction and dimension reduction. Because in healthcare we usually deal with high resolution image. So this image have the multi-dimensional. So it can be presented in circular forms. So you have the multi-dimensions. So it is one dimension, it is second dimension, and it is third dimension. So the dimension reduction is also important for the fast detection of the disease. And then we have the classification and clustering process, and we have the post processing for presentation. So here we conclude today's lecture, and we have the question and answer session at Zoom. Also, you can post your questions on LMS as well. So I expect you to start learning Python, because during the course I will give you assignments in Python in which you use NumPy, SciencePy, and Panda libraries, and ScienceKit for machine learning to use for different data mining applications. So if you have any problem in Python, so we can arrange an extra session over Python as well. Thank you very much.